Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take yet another look at our physics demo. If you've been following along with our little series here, you know that we have been working quite a bit on the different projectile problems as well as a simply supported beam problem. And if you followed along in all of the videos, you probably have a very, very large file at this point. It's probably already up around 800, which is definitely probably the longest code file that you have ever written. And that's, of course, including some extra spaces, some comments, but it's starting to get a little long. And more importantly, we'd actually like to be able to reuse this later. So what I intend to do in this video is show you how to clean up this main file, this physics driver.c, and actually start breaking your code up into several files that then you can use in other projects. So before we get started, the one thing I would encourage you to do is to go find your physics demo directory and go ahead and make a backup copy of your physics_driver.c, just in case you miss a step here so that you don't end up destroying your previous work. All right, so let's get started now on essentially dismantling what we've spent quite a bit of time working on. And so to begin with, in this example, what we're going to do is I'm going to first go ahead and create a header file and a new source file that we are going to put some of our code in. So in other words, instead of having a single .c file, now we're going to have multiple .c files. And so to begin with, what I want you to do is I want you to right-click on the folder in NetBeans and go to New Header File. And I want you to create a header file that's simply just called physics. And you want to leave the file extension alone. Okay, so we want to specify a .h file and hit finish. And then we can go ahead and take out the code that's here. As a matter of fact, we can go ahead and take out the default comments as well. And we'll come back to this. We'll clean this up a little bit. But for right now, I'm going to focus on the functionality. The second thing I want you to do is I want you to right-click on your source files, and I want you to go and I want you to create a new C source file. And I want you to call it the exact same file name. So in this case, physics, but with a different extension. So physics.c. And then go ahead and finish. And then once again, we can go ahead and clear out the default comment. You can change the template if you want to. Now, this is where things get a little scary. So what I want us to do now is I want us to split up the code that we have been working so hard on. And so to begin with, what I want us to do is I want us to take all of our prototypes, excluding our help. You want to leave your help where it's at, but I want to go ahead and take all of those prototypes. I want to go ahead and just cut them out, Control X. And then I want you to paste them over in this physics.h file. And while we're at it, we're going to go ahead and get rid of those comments that we had made earlier. They're still useful, but they're just going to be a little bit out of context now because essentially this header file doesn't know anything about how it's going to be used. And so it doesn't know about that command line application that we've created. So if anything, we're just going to clean this up just a little bit. And if anything, it's going to kind of go back to what it originally looked like when we started one of our earlier videos. So there we go. All right, we've grouped our projectile 1, 2D, and beam problems again. The second thing I want you to do is I want you to go ahead and take out this define for our AY. Go ahead and Control X and bring it over here. Now, the last thing then that I want us to do is go ahead and save this, but I want us to come back over here now, and I want us to add a new include. But this time, not with the angle brackets, but with quotes. And you'll see now that pops up a physics.h file. So essentially what we're doing is we're creating our own header file that contains the definitions for our functions, the prototypes for our functions that can then be used in multiple executables. And so in this case, you can go ahead and type it out manually, or you can simply hit tab. And so now what happens is the code here, or these prototypes, sit in a separate file that then will be referenced using this preprocessor directive. Now, the second step of this is going to be to go to migrate our code from our single physics driver document into the physics.c. And this is probably going to be the most terrifying part because we've spent a lot of time on this code. And what we're going to do is we're going to start down here with our projectile 1D version 1, and we're going to go all the way down including everything except for our help. And once again, you want to hit Control X. You don't just simply want to make a copy of it. You actually want to completely delete it. And then you want to come over here to your physics.c and you simply want to paste it in here. Now, at the top of the physics.c, you should probably already notice some warning messages here. Okay, particularly you'll notice here that an unresolved identifier. We're going to get to those in just a second. Don't get too worried about the red that you see there. There's going to be quite a bit of it because we haven't told the physics.c file what libraries we need to be referencing. In other words, what header files that we want to be referencing. So what you want to do now is you want to include anything that you may use. And so in this case, we'll go ahead and start with these 5. There's no reason just to go ahead and focus on these 5, not to focus on these 5. But then if you bring this over here, then essentially this .c file is going to be including the contents from the standard io.h, standard lib.h, the math.h, the string.h, but most importantly, the physics.h. So now our C code, our physics.c, is going to use this header file when looking for the function prototypes. What does this allow you to do? Well, among other things, code reuse. Code reuse, and then also you can provide this .h file to other developers so that they can then develop code based on these function signatures. In other words, you don't necessarily need to know how they do it, just as long as they agree to do it the way that you have done it. All right, so let's see if we have actually accomplished something or if we have just created a massive mess of our code. So I'm going to go ahead and build it. And you notice that we have a working executable. So we'll come over here. And just like in the earlier video now, you're still going to be able to call each one of your functions. As a matter of fact, I'm actually going to show you how this works just in the NetBeans. If you right click and now navigate, go to the declaration definition, instead of taking you to somewhere in your physics driver.c, it actually is smart enough to take you over to your physics.c. And if you click on the physics.h, you can actually go to the declarations. All right, so essentially what you've done now is you've broken your code up into 3 files. And so now your main here is only a little over 400 lines long, including the help function. And your physics.c then has roughly about the same number of lines of code. But the difference is then you can reuse your physics.c and physics.h in additional projects. And what I want to do now is I want to come over here to the command line one more time, and we'll clear our screen and we'll just test a couple of these and see whether anything has really changed. And so I'm going to focus on my physics demo beam version 2 parametric mode, where I provide 3 arguments, and sure enough, it still works. As a matter of fact, let's go ahead and test one of the ones that we didn't do earlier. And so we'll look at the physics version, the Beam version 4, and we're going to look at the interactive mode. And it asks us to provide the distributed load, the beam length, and then the number of points. And sure enough, it prints out both of our tables. So hopefully you found this quick introduction to libraries useful. We will use these more, but this was just meant to be a little bit of an introduction in that how you can separate out your code from your main, or your formula, in this case, your formula functions from your main. As always, hopefully you found this video useful. If you have any questions or concerns, don't hesitate to email me.